Hello everyone and welcome to this video on classification of digital logic families and characteristics of digital ICs. So this would be the first video in the series of videos that would be shown to you in the course of digital design, which has a course code as U18EC407. So moving to the first classroom discussion video on classification of logic families and characteristics of ICs. Before going to that one, we'll have a small introduction. I mean to say, first of all, what do you, first we'll be discussing, we'll get to the definition of what is this digital integrated circuits and what are meant for, how these are being manufactured. So first of all, the first one, when you take it up, the first one, okay, here in this one, most electronic systems which are reasonable for modern advances are based on digital technology. Mean to say, whatever the technology we are going ahead, it is purely based on the electronic systems. And these electronic systems are how they are being used in your circuits, how they are getting up in the circuits. So all the digital systems, computers and microprocessor are assembled from a simple circuits called as logic circuits. So here all all the electronic systems. So electronic system comprises of what? All the digital technology. And now digital technology is nothing but the computers and microprocessors are manufactured or assembled using of simple circuits called as logic circuits. Now coming to the logic circuits. Now logic circuits are building. The basic building block for logic circuits are what? Logic gates. And for do all this one, for the logic gates, we'll be going ahead. There would be a simple circuits comprising of diodes, transistors, resistors, or would be a mixed up configuration. You will be getting the logic gates. So one after the other, we'll discuss on that one. So what is a digital integrated circuits? Digital integrated circuits are circuits which are been using different circuit configurations and different production production technologies, and circuit configuration. So that would be a definition. This definition will bring you the topic of what is meant by digital integrated circuit in the first unit, logic families. So here, what we say that a integrated circuit, digital integrated circuits are a combination of circuit configuration. Circuit configuration may be to say it will be a configuration of resistor, transistors, and diodes. It would be a configuration of any other thing. Diodes would be there, transistors would be there, okay, MOSFETs would be there. That would be the circuit configuration. And production technology, the technology which is used to produce that one. So you are in any technology, that technology will be taken into consideration and it will be there. So each such approach is called as one set of logic family. This is the definition of logic family. So, so logic family is nothing but it is several different circuit combinations and digital linkers. So such one such approach, each such approach is called as a logic family. So coming to the exact definition of logic family. A logic family is a collection of different integrated circuit chips that have similar input-output internal circuit characteristics but perform different logic gate functions such as AND or XOR NOR, etc. So for this one, to explain about this one, I will be taking one example like TTL is there. TTL is having different integrated chips like 7400, 7402, 7404. All these will be having, so like 7400 is an NAND gate IC. It will implement NAND gate function. So once you understand that one, it is a different integrator which performs different logic gate functions but have the similar internal circuit characteristics, similar inputs, similar outputs. And to say high level and low level would be same. That would be the definition of a logic family. So these logic families are being classified into basically two major categories. The number one category is unipolar devices, and the second one is bipolar devices. Again, in bipolar devices, it is been in a sub classification. It has been done as not saturated and saturated technologies. So in unipolar, directly, what are the different unipolar devices you are using? Those are the technologies like PMOS, P-type MOSFETs, N-type MOSFETs, and complementary MOSFETs. These are the three configurations, circuit configurations. So here PMOS will have a 9 gates and NMOS will have a 9 gates, CMOS will have a 9 gates. It's not like only PMOS will be having a 9 gate and NMOS will be having another NOR gate or something like that. So it may implement certain gates or not. And unsaturated family, logic family means they doesn't move to the saturation. Actually, you know that a transistor characteristics, if you take it up, it could be going in three regions. One is a cutoff region, second one is active region, third one is what? Saturation region. If you are operating a transistor in cutoff and active, okay, this is a cutoff and active, then we say it as an unsaturated. If you are making a transistor to operate from cutoff to saturation, then we say it as a what? Saturated logic family. Under saturated logic family, basically three most important are there: RTL, DTL, and TTL. The first one was elementary was TTL, RTL. Developments were there made in the TTL, but still further improvements were made in the TTL, which is an improvised version used for motion. And again, in non-saturated, we are having Schottky TTL and M-typical logic. These are the two logic families you will be having in the unsaturated. Coming to the logic levels and V levels, you will be having different potential levels, I would say voltage levels, uh, voltage high level at the output. So this high level is the minimum required voltage which can be considered as an output high voltage. So whenever you are having a high voltage, we say it as a minimum voltage required considered to be as high voltage. Similarly, input level high voltage is the minimum voltage required to be recognized as high voltage. VIL, maximum voltage required at the output that still will be recognized as low level. Low level is the maximum voltage. High level is the minimum voltage. Similarly, this is the current flowing in the output under the specified load condition and in the logic 1 state. Which output is high. In an output is logic 1. This is the current flowing in the circuit. Output is low. At that moment, whatever the current is flowing is said as output flow. And when the input is low, which is flowing into the input when the specified H1 is applied as low. So these are the currents associated to the inputs low and output high. So four current levels, namely as IOL, IOH, relating to low and high voltages at the output, respectively, and IL, IIH, corresponding to the low and high voltages at the input of the transistor when the input is low. The next terminology we will be learning it about the fan out. Fan out is over here. This you can see one NOT gate is been put up over here. Now this NOT gate is been connected to different number of NAND gates. So here you can see 1, 2, 3, 4, and 5. 5 NOT gates are there. 5 NOT gates means totally this is the fan out is equal to 5. Now you can get an definition that using a one similar type of gate, how many gates can be connected? Similar configuration gate should be there. This is TTL means this is also should be TTL. So how many? The maximum number of logic gates of same logic family that can be drive reliably. So here it is not a condition that this is a NOT gate and this also should be a NOT gate. It is not like that. You can put up a NAND gate, you can put up a NOR gate, anything over there. So how many gates you can put it up? That is nothing but the fan out. So fan out is nothing but a good fan out is a very good circuit. Now coming to the propagation delay. Propagation delay. The terms over here, how a signal is been propagating in the circuit. Now when you check up this circuit, when you apply an input, when you apply an input, at what instant you are getting the output. If you consider a NOT gate, when you are applying an input at the NOT gate, at what instant you are getting an output as output. So when you apply 0, when the output becomes as 1. So usually, as we told you, this NOT gate or any circuit will have, in the first definition itself, I told, it would be logic gates themselves have a simple electronic circuits comprising of diodes, transistor, resistors. So to flow a value from one end to the another end, it has to pass through the resistors and capacitors, all this one. So it would be delayed. So when you are applying an input as low, it would be high at that moment. Once I change it up, input from low to high, once we have reached to the high also, the output is not at all changing. So we will be taking into consideration of 50% of input changes from low to high. At the same time, how the output changes to the 50%. We'll take these two values, and when we take the ratio of these two, we'll get the propagation delay. TPLH, propagation delay. These two terms, if we take it up, we will get the propagation delay of the circuit. The next one is noise margin. Noise margin is one of the most important key factor because if at all any small noises are there in abnormal changes in the voltage or output changes over there. Now, how these would be considered as a high voltage, how this would be considered as a low voltage. And here, this would be taking into consideration of two things. One is an input voltage levels would be taken into consideration and the noise margin would be decided. Now, V is nothing but the minimum voltage required to be considered as a high voltage, and VIH is nothing but the minimum voltage required to be considered as at the input to be considered as a high voltage. So, when you are applying a minimum voltage VIH and what is the corresponding VOH minimum voltage, that would be given you the noise margin. So here you can see this is our input. Now this is my input over here and output is been getting over here. So this is the noise margin. Noise margin means even any signal considers over here in between this one, it would be considered as logic one. So noise is nothing but a signal which is one, it would be considered as low, low would be considered. Similarly, this is the noise margin you will be having when you go for the logic 0. So thank you. These are the characteristics and the classification of logic families. More videos would be uploaded in the next